So now my calculation is complete. Let me go to the my neb.output file, and if I go a little bit up, maybe I should open the output file and it will be more easier to see. So what this NEB-TS do is that, because I have given pre-obtained is equal to true and my initial structures were optimized using PM3, XTB. So first it will do is that it will try to optimize in PM3. So this is, I believe, my reactant optimization, and this is my, now the product optimization will start. So this 15 cycles, so the product optimization has taken actually some time. Maybe I have to go down a little bit, maybe another cycle more. So after 26 cycle it has attained convergence, and now it will start the impedance. So image 6 will be converted to a climbing image after this one, and then this climbing image will be optimized. So NEB optimization and is converged, and after the NEB optimization is done, it will start that optimization of the geometry of the TS. So the optimization has been converged, I think, only after 4 cycle, and then it calculates the frequency. By doing numerical gradient, and you see that the imaginary mode is same as what you have got for the from the relaxed optimization. So the same imaginary frequency 506, and if I want to visualize this one using ChemCraft, this is how it will look like. This is the imaginary frequency and it corresponds to reaction coordinate. Now just visualizing it, one can of course see in this simple reaction that what this transition state is correspond to, is it actually correspond to the chemical reaction. If I want to have a more quantitative proof of it, then what I am supposed to use is what actually call an IRC calculation, or intrinsic reaction coordinate calculation. IRC is an imaginary minimum energy trajectory passing through the transition state, which moves infinitely slowly from TS to the reactant and the product. So this is the keyword through which you should give the corresponding IRC calculation. And after what it does is that after initial energy and gradient calculation, it start to do the IRC procedure. So the output file will look like this one. Forget the number of atoms, it's for a different system. So this is what happens in an IRC. Start from the TS, it goes in the forward direction to the product and the backward direction to the reactant. So if I do not provide any Hessian or specify the Hessian calculation in our input, what ORCA will do, first it will calculate the numerical frequency, and after this computed frequency will be read automatically, and the forward IRC calculation will be done first, and then the backward IRC calculation will be done, then the whole path will be summarized. And this is where the various useful file will be written. So base name IRCF is the endpoint of the forward run, so most probably it will be close to the product. The base name IRC underscore F dot traj XYZ will be the trajectory. Similarly, base name IRC underscore B is the endpoint of backward run. Most probably correspond to the reactant, and the corresponding underscore traj.xyz contains the trajectory, and full trajectory of the thing is contained in the full trajectory. The endpoint of IRC are not fully optimized structure, and subsequent geometry optimization should be performed to obtain the final reactant and product structures. Okay, so let us now run an IRC calculation on the same geometry. So in this case, my NEB.xyz actually contains the geometry of my final transition state. So what I should do is that I should start from this one. So let me make an input file. And the input file structure looks like this. Maybe this is not very large font, but I can copy paste and put them in the notepad, then it will be more visible. So it will be PM3 and the keyword is just IRC. How many iterations you require is max is iter 30. Generic number, default number of iteration is 17, and in this case this should be neb.xyz. So we need to go to a directory TS, and let me keep the name CH3FCL. ts.inp, and remember this has to be our input file. So we can run the orca 3CL F CH3F. CH3 FCL TS dot out. Okay. So the problem is that for this complex this should have been -1 and 1. This we have not done properly, so that's what the mistake. You can say that the error says the multiplicity is 1 and the number of electron is odd. So first, as we discuss, it is calculating the numerical frequency. So this is my Hessian is calculated. This is the forward IRC calculation is happening. So it's coming from the top of the transition state. So what it is now doing is that it's the energy is increasing. Sorry, the energy is decreasing. So it's coming from the top of the transition state and it's coming in the forward direction. So the energy has to decrease. So you can see the initial change was very steep. Now the change has become smaller. So it's coming down the slope. So the forward IRC calculation has been converged. Now it's going backward. Here also the energy will start to decrease. So even the backward IRC is also going towards convergence. So now the IRC calculation has been done. If we open the main output file with ChemCraft, so of course the single point geometry. So it will not tell you so much thing. Maybe you should open the IRC full trajectory where it contains the both forward and the backward, and if you open it with ChemCraft, and if you see the animation, so it basically leads to the forward IRC where it's the fluorine group is leaving away and the chlorine group is forming the bond. And if you really want to see the backward IRC, see, this is the backward trajectory.